Hello everyone, my name is MD Khairul Islam. Welcome to my presentation of chemistry of honey. First of all, I like to sincere apology on behalf of Dr. Liz Barber for her unavailability of this meeting. Today, we're not going to give you a chemistry lesson, but talk about honey adulteration, how aspect of it evolve and the chemistry used to try and detect those adulteration. Visually telling the difference between two jars of honey, it became extremely difficult, as you can see from this picture. Australia has been a lucky country, especially where beekeeping has been concerned. Our beautiful, pristine forest and a burst of spring flower with a bioactivity that is envy to the apiculture world. This is all because the flora evolved to contribute the energy requirement of our marsupial and birds, producing ample amount of nectar and pollen. Without mass hunting for flower, the Australian migratory beekeeper broke honey production record, moving from one flowering event to the next. This resulted in our present industry structure, a lot of family beekeeping business with a small number of large packer. And it has thus packer that blended the different types of honey to make a single flavor blended batch. They also brought in the expectation that honey shouldn't crystallize and could actually be squeezed from a plastic bottle. They made honey no different to sugar syrup, and it was priced and treated as such. Most honey naturally crystallize. Crystallization is the result of sugar composition and the pollen content, as well as the other bits of the colony caught within the honey. A high glucose content, the honey will crystallize as this glucose is not as soluble as fructose. There are very few honey types sourced from our flora that do not crystallize. The other factor is the pollen, which can act as a crystalline seed that can initiate the crystallization process. Our honey, because of the diversity of our flora, on average has 7 pollen count within the honey matrix, with the exception of an easily pouring honey, the honey packer heavily processed honey. With this change in process, so the honey taste also evolved. What was raw honey sold to the packer became a product that now needs testing so that it can still be named as honey. There are a number of standards that are agreed upon by international community to define honey. The European follows Codex, the American follows USP, United States Pharmacopoeia, and there is a new IC standard being developed which has included a large number of the countries. Each of these standards have different tests which measure aspects of honey that they think is important for their consumer. If you want to see the details of each of these tests, they are on our website. Normally, our honey are extracted at below 16 to 18% moisture. But if you look at the definition of Australian honey, the water content can be as high as 21%. This is well over any international standard. Alternatively, some beekeeper harvest before the honey is kept so the moisture content is high. Packers have now the equipment that extract the water from the honey. That's why on the social media, there is that pure honey test with a spoonful of honey is drizzled into a glass and its structure remain intact to show pure honey. In the laboratory, the test used for the standard is called moisture content. To pick up the honey drying, A sugar analysis is required as the sucrose level will be remain high as the enzyme would not have enough time to break down the sucrose to glucose and fructose. With some honey types that require aging, like Manuka, they would store the honey before filling for the enzyme activity to continue, which is also an advantage for building up their activity or active ingredient, which we will discuss later in this talk. To pick the honey in large quantity and quickly, heat was used to make it more liquid. Instead of stirring, a filtration of the pollen from the honey matrix can occur. Pressure is often used to move the honey through quickly. If you have a microscope, you can look at a honey drop to see if it has pollen. In the laboratory, the standard test for checking the filtering level of honey is water-insoluble solid content. Heating changes the chemistry of honey, also its composition. A substance called 5-hydroxymethyl in short HMF, is produced from the breakdown of the sugar product. If the amount of this HMF goes above 40 milligram per kilogram, then the living part of the honey has been destroyed. This is because heat over 40 degree denatured the natural enzyme in the honey. The easiest enzyme to mature is diastase, but invertase can also be measured. Diastase breaks down complex sugar into simple sugar. On the other hand, invertase breaks down sucrose into glucose and fructose. Their enzyme activity needs to be above a certain level to show that they are still active in the honey. So, unless the honey type has been naturally high fructose level, if the honey is not showing the sign of crystallization, they may well be seen as adulteration occurring. For you at home extracting your honey, no water should be added, as well as the extraction temperature should not reach above 37 to 40 degrees Celsius, and the honey only be settled and strained at most. This will ensure that you have produced raw honey if you have followed the Australian standard in beekeeping. Australian Honeybee Industry Council, or ARBIC, through its company Beequal Australia, has established bee trays for you to manage your husbandry record as well as hatch up. Australia's honey production has been on a steady decline. When you looked at the decline in our forest area, and with our forest still rapidly declining, as a honeybee industry, we are in trouble of losing our iconic honey types. Perhaps even more concerning is the misplaced belief that prescribed burning is protecting us from fire. And this, together with poor farm management, that leads to the endangered protection of natural farm. We need a major change to stop this native flora from declining. We're not alone in this loss of flora. It's happening throughout the world. And to keep honeybee colony alive, especially in dry climate, a tool beekeeper starts using was feeding their colony with sugar syrup. If there was some pollen coming in, this syrup boosts the colony and assisted them through winter. But these tools over time became an artificial nectar source for the sole use of producing honey. To start with, chemists can easily pick this up. Man-made syrups are extracted from heat, extracted with heat from plant material and hence have a high HMF, which is transferred to the honey. Additionally, Many of these syrups are maltose based, which is a double fructose molecule, messing up the fructose to glucose properties. So, this adulteration can be picked up either via HMF level or the sugar proportions. But we are human, and both of these issues were overcoming with the development of a new artificial sugar that has both glucose and fructose and no HMF, making it almost impossible to chemically to pick up the sugar feeding. This use of sugar level is further complicated as no two nectar sources are alike. While genuinely honeybee favor certain sugar portion in their nectar, when they are starved, exception do occur. For example, for us in the southwest of Western Australia, Jarrah nectar produces a high fructose honey, whereas Mary nectar produces a high glucose honey. Honey standards try and make one size fit all, and the committee that sets these standards is loath to make exception. This does not favor Australian honeybee industry as generally because of the history blending of honey. Also, the properties of our honey types are unknown. It has been a long held opinion that sugar cannot be used to detect adulteration. Producing a honey type that is dominated by a single nectar source in an area of honey marketing that Australia is now embracing, where packers would not go therefore. They are now using honey type in their marketing and describing flavor, color, as well as the bioactivity. For a beekeeper, this takes skills of managing the colony, as well as predicting the flowering event so that there is minimal carryover from the last flowering event and the new flowering event comes in as expected. Also with sufficient flower to fill the honey box. A plant can flower. The flower can open, but there might be no nectar. If there is nectar, a typical nectar cycle is in peak in the morning to drop right off in the middle of the day with a slight recovery before the sunset. If there is no groundwater, the nectar flow doesn't occur. Nectar production has been a botanical mystery. No one system is common to all nectaries. So this makes the substance they produce changes between species. We can talk nectar all the day, as it is fascinating how the plant has manipulated its chemistry to attract different type of pollinator it actually wants. The other fact to consider is that flowering is not an annual event for most plants. Producing monofloral honey is a rare event, and their price should be reflected as such, which the packers are using in their marketing. The New Zealand lead this concept of monofloral honey with Manuka honey. This is really an amazing story in the marketing facts. Some facts are such that Manuka honey is not a monofloral honey, and hence the problem they had with their trademark court case reliance on the name of the honey, not the honey itself. It actually never met the definition of a honey, but they have methodically introduced exception into the new ISO standard to now get into accepted. The MGO inactivates enzyme, so as the DHA, which comes from the nectar of Manuka flower, ripened to the form of MGO over time. The living honey lost its enzyme activity. It can be adulterated via sugar, dehydration, and their bioactive ingredients like DHA and MGO can be brought off from the shelf and added to the honey. Because of all of this, it was the most adulterated honey in the world. The New Zealand honeybee industry was forced to protect their product. This solution has taken a while and many outstanding scientists, even some from Australian contribution. But the resulting testing is exceptionally expensive, covering 5 tests that require 3 pieces of equipment, including the DNA analysis. They are lucky Manuka honey can attract a high price. On the other hand, Western Australia have its iconic honey Jarrah. At Whiterace, we developed a novel analytical technique to produce the Jarrah honey phenolic signature. As you can see in this picture, this phenolic signature is unique to this Jarrah honey and can be traced back to its nectar source. We also identified different substances in this honey phenolic, which we can use to authenticate the Jarrah honey. 4 of the substances are known, one of the substances we haven't been able to identify, thus concluding it is unique to and rare in the nature. Honey has been used for its bioactivity, which can be linked to its antibacterial activity. The original phenol equivalent assay is so unreliable that the Manuka honey they never uses the total phenolic activity. They move to the MGO content which claim to link with the bioactivity. But at our chemistry honey analysis lab at Whiterace, we developed a new way to measure the bioactivity, which is far more reliable and reproducible than the phenol equivalent assay. The total bioactivity can be linked to its MGO content, especially for Manuka honey. The conventional or original phenol equivalent assay only gives a certain range. The highest range can be possible above 50 plus. Above that range, it is almost impossible to reproduce the result. But at our lab, the new developed method can accommodate the low antibacterial activity as well as the highest one. Thanks everyone for listening to our talk.
Thank you. Hi, Carol. So I'm a
Yeah.
hobby beekeeper. So just at home in the backyard. I know where my honey is coming from, but I don't know which trees the bees are getting the nectar from. Is there a way for us to do a honey DNA testing so we can get a report that says what percentage is from a fruit tree or some other trees?
Okay. Thank you for your question. Actually, the honey DNA test, when you do the honey DNA test, we actually do the DNA testing of the pollen that actually present in the honey. So, and you all know that the bee might collect the pollen from the different plant that they are not collecting the nectar from. So, if we just rely on the DNA testing, we might not be able to get a complete picture of the honey. We only get the picture of where the pollens are actually coming from. So to get a complete picture of where actually your honey is coming from or the nectar is coming from, we have to analyze the chemistry of the honey. So that's why in our lab we have developed a novel analytical technique to look into the non-sugar part, especially the phenolic content of honey. So in our lab, we have the capacity to analyze the phenolic part. One limitation right now we only tested most of the Western Australian honey, couple of honey from East Coast, especially from Tasmania, the Tasmanian leatherwood honey, from Kangaroo Island, and also a couple of group of honey sample from Victoria and New South Wales. So if your honey falls within that particular group of range or the chemistry, then obviously we can pick it up. I think you got my answer.
Another question here.
Hi, I was just wondering, you said Manuka honey is not a monoflora honey. Can you please explain that a bit more?
Okay, thank you for your question once again. So in our field study, we have find out that the Manuka tree, the leptospermium tree, actually produces really, how can I say, in terms of the nectar quantity, is not sufficient to produce a vast amount of honey. So, and when we analyze different, how can I say, type of Manuka honey that's claimed as Manuka, if their chemical signature, and we say a vast difference in their chemical signature, especially the chemistry of honey is different. That's why the New Zealand actually went for identifying a specific marker compound. If that marker compound like MgO or DHA or leptospirin is present, then they claim it as a Manuka. But that doesn't mean that honey doesn't have the other thing or other honey content. So in our lab, when we analyze a group of honey that claimed as Manuka, we haven't find any consistent chemical signature. We find a variety of honey signature along with their typical constituent like DHA, MgO, or leptospirin. So it actually give us a certain conclusion that this is not a pure monofloral honey, but it contains the marker compound. Thank you, everyone. Bye.